Random variables. We have discrete and continuous random variables. A random variable is a numerical outcome of a probability experiment. And we usually use uppercase letters to denote the random variables. We have two main kinds, discrete random variables and continuous random variables. And discrete random variables are the variables whose possible values can be listed. 0, 1, 2, 3, 4, 5, and so forth. The list may be infinite, but it's countable. Right? So the list of whole numbers, there are infinite number of them, we can count them. Continuous random variables are that can be taken any values in interval. The possible values of continuous variable are not restricted to any list. Okay, so that's essentially the difference between discrete and continuous random variable. So how do we relate this in context of probability and probability distribution? So in this video, we're going to look at discrete random variables. So consider a coin tossed twice. Let x, this is the random variable, be the number of heads that appear. Find the probability distribution of x. So probability distribution of x, right here. Let's list all the possible outcomes. We can get head, head, head and tail and heads, and tail. So all these are in the sample space. This is the sample space. So how can we relate this in terms of random variable? Well, x is number of heads that appear. So in this case, x will be 2. Here has appears once in this case. Has also appeared once here. And here has appeared 0 times. So we can organize this in a table. We call it probability distribution. X can be 0, 1, or 2 in this case. And we write down corresponding probability for each random variable. So total there are 4, and there's 0, there's only one case for 0. So this will be 1 out of 4, which is also 0.25 if you write in decimal. For 1, there are 2 out of 4, which is 0.5. And for has to appear twice, there's only one of them, so it's 1 out of 4 again, just like 0, 0.25. So of course, if we add all these up, we get 1, because probability distribution, all the probability should add up to 1. Okay. So key ideas for probability distribution. Let Px denote the probability that a random variable has the value of x. So x can be, as we saw earlier, 0, 1, 2, 3, and so forth. And each value of x, each probability is between 0 and 1. It could be 0, it could be 1, but it has to be between 0 and 1, including. And of course, the sum of all the probability should be equal to 1. So let's look at this example. Which of the following table represents a probability distribution? Why don't you pause the video and try to figure it out on your own? So the answer is either yes or no, right? Yes, it is a probability distribution. No, it is not a probability distribution. So take a few minutes and try this problem on your own. Then when you unpause it, I'll go over it. So let's look at first one. Well, first one, we can look at this number right here. We cannot have a negative probability. It must be between 0 and 1. So since this number is not between 0 and 1, this is not a probability distribution. No, answer is no, not a probability distribution. A is not a probability distribution. Something is wrong here. How about second one? Second one, well, there's no negative values in probability, so that part is good. And you may be alarmed at the fact that we have negative values in x, but that's okay. This is whatever the x is saying that whatever context is, we have negative 1, negative 0.5. That is okay. What matters is that we have a finite number of these. Well, we could have infinite too, but we can at least list them. And also, we have to check if we add all these, if we get 1. In fact, it does. So if you try to add on your own, if you add all these numbers, you should get 1. So yes, it is a probability distribution. See, also if you add all these, first of all, none of them are negative. All numbers are between 0 and 1. So if you see a number bigger than 1, that's also not a probability distribution. All the numbers are between 0 and 1. All the probabilities are. And if you add all this, you also get 1. So yes, this is a probability distribution. So for a discrete random variable, or for a discrete probability distribution, we can find the mean. And this mean is different from what we learned earlier. This is not an arithmetic mean where we add all of them and divide by how many we added. That is not what we're doing. And I'll show you how we calculate. So the mean of random variable or expected value. So these two means the same thing, mean or expected value in context of discrete probability distribution. So to find the mean of discrete random variable, multiply each possible value by its probability, then add the products. Okay, and this is the formula. So this is mean of distribution x, and we add all of them of x times its corresponding probability. We add all of them. Okay, and the mean of random variable is also known as expected value. That's the value we could expect, not guaranteed, but expect. So let's go over an example here. A computer monitor is composed of a very large number of pixels. It is not uncommon for a few of these pixels to be defective. Let x represent number of defect pixels on a random chosen monitor. The probability distribution of x is shown as below. Find the mean number of defective pixels. So let's go over the table. What this table is telling us is the probability of having 0 pixel being defective is 0.2. Probability of 1 pixel being defective is 0.5. Probability of 2 pixel defective is 0.2, 3.1. And of course, if this is a correct distribution, if you add all these numbers, we should get 1. So how do we find the mean? What we do is we multiply each variable to corresponding probability. So I will be doing 0 times 0.2, 1 times 0.5, 2 times 0.2, 3 times 0.1, and I add all of them together. So let me write that. So I'll do 0 times 0.2 plus 1 times 0.5 plus 2 times 0.2 plus 3 times 0.1. So we add all these numbers. So well, let's multiply first. 0, 0.5, this would be 0.4 plus 0.3. And expected value we get is 1.2. So let's be clear that this number we get here, this is not a probability value. 1.2 is not a probability. 1.2 is the expected number of pixels a computer could have. So we can expect a computer to have 1.2 pixel. So if we pick 10 computers, we can expect to have total of 12 pixels that are defective. If we select 100 computers, we could expect to have total of 120 defective pixels. That's what this number means. So we're finding essentially a mean value in context of probability distribution. But because each variable has different probability, we can also think there's a different weight. That's why we multiply them and then add all of them. So let's look at binomial distribution. Binomial distribution is also discrete random variable. So there's some few conditions for a binomial distribution. So let's go over one at a time. First, the fixed number of trials are conducted. So for example, if I toss a coin, I need to toss a coin fixed number, maybe 100 times, 1,000 times. Although that's a large number, it has to be fixed number. And there are only 2 possible outcomes for each trial. So either success or failure. So if I think coin toss as this binomial distribution, I can declare getting tails as success, and then not getting tails is failure. So there are only 2 possible outcomes. And probability of success is same on each trial. So if I for coin toss, 0.5 will be probability of success every trial. And the trials are independent. This means that the outcome of one trial does not affect the outcome of other trial. So my first coin toss should not affect my probability of second coin toss, and so forth. Note when a simple random sample comprises less than 5% of population, we'll consider sample individuals to be independent. Okay, so that's just in general. The random variable x represents the number of success that occur. Okay, so the notation, we use number of a trial as n, and probability of success is denoted by p, and probability of failure is noted by 1 minus p. We can also note as q sometimes. So let's determine if below two examples, the x is a binomial random variable or not. A fair die is rolled 20 times. Let x be the number of times the die comes up, 6. Well, here, the success, this is what we consider success in this problem. Okay. And probability of getting success, let's say 6, is 1 over 6 every time because it's a 6-sided die. And is rolled 20 times, so n is 20. So this is the binomial distribution. Because there's clearly only a finite number or fixed number of trial, and we have a clear definition of success. So success is getting 6, and failure will be not getting 6. And for each roll, the probability of success is same, 1 over 6. How about scenario B? A standard deck of 52 cards contains 4 aces. 4 cards are dealt without replacement from the deck. Let x be the number of aces. So without replacement means we do not put the card back. Once I select the first cards, I do not put it back the second card. So the first draw or first deal, the probability of getting ace, there are total 4 aces. So it's 4 out of 52. But for second trial, getting ace, it will be 3 out of 51. And they're not same probability, right? And of course, for the third, it will be also different. Third one getting ace will be 2 out of 50, which is also not same. So therefore, this is not binomial. So there's several things we need to consider when determining binomial or not. And all those are written right here. Fixed number of trial. Well, in this case, the card example was fixed number of trial. There are 4. Oops, let me read it again. 4 cards are dealt, right? So we're dealing 4 cards. It's fixed number. 2 possibility outcomes. Yeah, either ace as a success or not ace as failure. So that's okay. But this problem fails the third condition. Probability of success is not the same because we do not put the card back in. The second card, we have 1 less card to choose from. Hence, the probability is different. So it's not binomial. So let's look at the formula for the binomial probability. And you do not need to memorize this formula. This formula will be given in the exam, midterm, or final exam. So you do not need to memorize this formula. You just need to know when to use it and how to use it. So if we know if a random variable is a binomial random variable, it's very important. So you need to really practice thinking about how to recognize it's a binomial. Then we can use a formula to find the probability that x occurs. So for a binomial variable, represents number of success in n trials, with success probability of p. And the probability of obtaining x success is probability of x equals c and choose x. I'll talk about this in a second. The probability of success raised to x, whatever x is, 1 minus p raised to n minus x. And this part of the formula right here, n choose x, is this right here. N factorial over x factorial times n minus factorial. And factorial is multiplying. So for example, 5 factorial is 5 times, 4 times, 3 times, 2 times 1. 3 factorial is 3 times 2 times 1, which is 6. In this case, 120. Because that's what factorial is. And possible value for x, this is very important, is 0, 1, 2, all the way to n. whatever n is in the problem. Make sure to don't forget the n. Sorry, don't forget the 0. So let's look at a problem and you apply this formula. The Pew Research Center recently reported that approximately 30% of internet users in US use Pinterest. Suppose a simple random sample of 15 internet users are taken. So this is the n, total trial. Use a binomial probability distribution to find the following, round to 4 decimal places. So first, it's asking, find the probability exactly 4 of sample people use interest. So the main question of binomial distribution probability problems are, out of n trial, what's the probability of getting x number of them as a success? So here it's asking, if I select 4 people, what's the probability that exactly 4 people use Pinterest? So let's apply the formula while we're doing probability P of 4. So we use this formula. Well, before actually we use the formula, it's good habit to list all the variables we need. Well, we know n is 15 in this context because total 15 internet users. X is 4. That's the specific variable we want to use to find the probability. Well, P is probability of success is 0.3. 0.3, 30%. So put that into formula. Probability of 4 equals, I'm just using this formula right here. Let me highlight it. This right here, the top. Well, n factorial, 15 factorial over x 4 factorial times 15 minus 4 factorial multiplied by 0.3 to raise to x is 4 times 1 minus 0.3 raised to m minus x. Well, 15 minus 4. So we can simplify 15 factorial over 4 factorial times 9 factorial. This is 9. This is also 9. Times 0.3 to the 4th. This is 0.7 to the 3rd power. Okay, so let me go over how you can type this in your calculator when you do this. So it's good habit to do one at a time. So let's calculate this first. So let me do it right here. 15 factorial over 4 factorial times 9 factorial. Well, we could actually list it, not all the numbers, but at least the beginning number. We know 15 factorial means 15 times 14 times 13, 12, 11, 9, oops, forgot 10. 10 times 9, 8, all the way to 3 times 2 times 1. Divide by, we know 4 factorial is 4 times 3 times 2 times 1. Multiply by 9 factorial is 9 times 8 times, all the way to 3 times 2 times 1. Well, if you look at here, this will always happen, at least in this kind of problem in our class, is that some of the factorial will cancel out when we multiply. So here we have 9 times all the way to 1. 9 times all the way to 1. So these two cancels out. They're the same number. Therefore, what we have left here, oh, I apologize. I just realized I made an error. It's actually not 9, right? 15 minus 4 is 11. I don't know why I wrote 9. So 11 factorial and also 11 power. So we can still use this idea. Let me erase the green part. So actually 11 factorial here, 11 factorial. So let me write this part again. It will be 11 times, 10 times, 9 times, 8 times, all the way to 3 times, 2 times 1. So then we know that this portion right here, 11 times all the way to 1, 11 times all the way to 1 cancels out. So only thing we have left for this portion is 15 times 14 times 13 times 12 over 4 times 3 times 2 times 1. Okay. So this can be reduced to this. So when we do this calculation, is 15 times 14 times 13 times 12 over 4 times 3 times 2 times 1. So you do this number first in your calculator, put in parentheses, then multiply by 0.3, raise. The raise part is this button right here. It looks something like this in most calculators. Raised to 4th power, multiply by 0.7 raised to 11th power. So, and again, it's also good to keep the parentheses. And if you type in your calculator, you should get 0.2186. 2, 3, and it goes forever. But since we're running to 4 decimal place, our answer is 2186. So what does this mean? This means that the probability of exactly 4 people who are using Pinterest is 0.2186. So in same context, let's find the probability that fewer than 3 people use Pinterest. So fewer than 3 means, again, build a habit of actually listing it. Fewer than 3 means x equals 0. Don't forget 0, 1, and 2. So there are 3. So we're finding probability of 0 plus probability of 1 plus probability of 2. We add all 3 of these, then we get the probability of fewer than 3 people use Pinterest. So how do you find each of these? We use the formula 3 times. So let me actually write vertically to organize better. So I find probability of 0 using the formula probability of 1 using the formula probability of 2 using the formula. So I'm using this formula right here. This right here. Again, you do not need to memorize this formula. It will be provided for you. So let me write the numbers using this form, each value. Well, for all of these, n is same. N is 15. P is still 0.3. Only x value changes. So for this one, I do 15 factorial over 0 factorial. Let me actually zoom in to write it better. Times 15 minus 0 factorial. 0 factorial is actually 1. So that's something you have to remember. 0 factorial is 1. 1 factorial is also 1. Multiply by 0.3 to the 0 power. And times 1 minus 0.3 to 15 minus 0 power. So let me highlight this part that are changing. These are 0. These are the x, where the x goes. Right? Everything else stays the same in the next formula. 15 factorial, in this case 1 factorial, 15 minus 1 factorial, so this will become 14 factorial, times 0.3 of 1, 1 minus 0.3, 14 minus 1. Again, in this case, only thing they're changing is the location of x, which is numbers changing. Oops, not that one, this one. Lastly, probability of 2 is 15 factorial over 2 factorial. 15 minus 2 factorial times 0.3 to 2 power 0.7 to 14 minus 2 power. So you type each of this in the calculator, and let me give you each number. So make sure to practice these on your own, typing in your calculator. So this you should get 0.004748. This one you get 0.03052. And the last one you should get 0.09156. And here I kept more than 4 decimals because usually we want to keep more decimals in mid-step but round it in the final answer. So if I add all these, add, then I get about 0.1268. So that is the, well, 6828, but I'm going to round to 4 decimal. So this is the probability that fewer than 3 people use Pinterest out of 15 people when when we select. Probability of selecting 0, 1, or 2. So let's look at part C. Find the probability that more than one person uses Pinterest. More than one means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So here, ideally, theoretically, we could find the probability of all these and add them. P of 2, P of 3, P of 4. But there's a faster way of doing it. We can use the idea of complement. So we want to find, let me write it here, probability of 2 plus probability of 3 plus all the way to probability of 15. But instead of finding this directly, what we can do is 1 minus probability of 0 and minus probability of finding 1. So in that case, we only need to apply the formula twice. So we're finding probability of actually less than or equal to 1, and then subtract the number from 1. That's what we're doing. So we already found these 0 and 1 earlier. Find the probability of 0 is actually 0.004748 from here. And probability of exactly 1 is 0.03052. So if I do 1 minus these two numbers, I get about 0.9647. So this is just more efficient way of calculating rather than finding P of each of these individually so many times, right? Last, find the probability the number of people who use Pinterest is between 1 and 4, inclusive. So between 1 and 4 inclusive means probability of 1, probability of 2, probability of 3, probability of 4, and add all of them together. So that means we're applying the formula 4 times and add all of them together. Well, we already found 1 and 2 from the previous steps. Right? Well, 1 was 0.030305, probability of 2 was 0.909156. 4 we actually found step A. Which was, where was it? Right here, 2186. So we need to find P of 3 using the formula. And you should definitely practice finding these on your own, how to also using the formula. So let's find probability of 3 using the formula. So we have 15 factorial over 3 factorial times 15 minus 3 factorial times probability is 0.3 to the 3 times 0.7 or 1 minus 0.3 is 0.7 raised to 15 minus 3. So this gives us 15 factorial 3 factorial times 12 factorial times 0.3 to 3 times 0.7 to 12. So if you do this calculation in your calculator, you should get something close to 0.17004. So probability of getting exactly 3 people use Pinterest is 0.17004. So for this problem, we add all these 4 numbers. Then we get 0.15072, but we're running to the 4 decimal, so this is good. So this is the probability that number of people use Pinterest is between 1 and 4 out of 15 people. Let's look at one more example. According to Experian Automotive, 35% of all car-owning households have 3 or more cars. In a random sample of 20 car-owning households, find the following probabilities. So here n is 20. Total trial. What is the probability of exactly 5 households having 3 or more cars? So this is x, and having 3 or more cars is defined as success in this case. Right? So don't get confused just because success is defined with numbers in this case. This just means success. So only thing we have to worry about in terms of numerically is this 5 for this problem. So we are applying, well, let's write all the values. N is 20, x is 5 in this for part A, and probability is 0.35. So let me copy then the formula here. N factorial over x factorial times n minus x factorial times p to the x times 1 minus p to the x, n minus x. So here we're finding probability of 5, or 20 factorial over x factorial, 5 factorial, times n minus x, 20 minus 5 factorial. So we're doing this subtraction first and then factoring the number. So let's actually write as 15 factorial. 20 minus 5 is 15. 15 factorial times p is 0.35 raised to x is 5. 1 minus p in this case 0.65 to 15 power. So as we saw earlier, we'll try to do this calculation first. When you simplify this, what will happen is 15 factorial and 15 factorial on the top will cancel out. So in the numerator, we've only left with 20 times 19, 18, 17, and 16. Because 16 multiply 14 all the way to 3 times 2 times 1 will cancel out with this 15 factorial in the denominator. So that's all in the numerator, and denominator we get 5 times 4 times 3 times 2 times 1. Multiply by 0.35 to the 5th power, 0.65 to the 15th power. And yeah, if you're comfortable typing this entire thing in your calculator, you should go and do it. But if you want to be more careful, we can always find this number first. And this number should be always a whole number. If you do not get a whole number for this, that means you're doing something wrong. So this number is 15504 times this number and this number on your calculator. It should give you 0.1272. So that's the probability of exactly 5 households having 3 or more cars. What is the probability less than 4 households? Less than 4. So again, we have to be careful wording here. Less than 4 means not including 4. If they want you to include 4, it should have said less than or equal to 4. Since it just say less than, we list numbers that are less than 4. Don't forget 0, 0, 1, 2, and 3. So the way we can write it is probability of x less than 4, which is adding all 0, 1, 2, and 3. Add all these numbers. Okay. So for 0, well, all of these, the n value is same. N is 20. P is also same, 0.35. X value changes. X is 0, X is 1, X is 2, X is 3 times. So here we apply the formula 4 times and add all the each probability to get the probability that less than 4 households have 3 or more cars. So let's write the formulas. P of 0 equals, let me write it first. Let me write all of them first. So here I wrote all the formulas for each random variable. Again, the things that are changing are these numbers, right? You notice 1, 1, 19. Well, these numbers also change. 2, and these numbers. So quick note, this one, 0 factor is 1, so this one just is actually 1. 20 factorial divided by 20 factorial is 1. And anything to 0 powers is actually also 1. Therefore, this one you're just doing 0.65 to 20th power. Should give you 0.000181. And for second one, simplify this first, multiply these. You should get 0.001952. For this one, 0.009985. This is 17 right here, because 20 minus 3 gives us 17. This one gives us 0.032258. So add all this together, add, then we get 0.00, 0.0445. So pay attention to this wording in these problems. So before I end this video, let me go over the characteristics of binomial distribution. Binomial distribution is always a fixed number of trials, and it has only two possible outcomes. Two possible outcomes in each trial. We define them. So in previous example, the success will be having 3 or more cars, and failure will be not having 3 or more cars. Right? So success, failure should be clearly given in the problem. And probability of success is the same each trial. So in the household car problem, the probability of success always was 0.35. Trials are independent. The random variable x represents the number of success that occurs. So essentially, what we want to find in binomial experiment is find the probability of x number of successes out of n trials. So that's the central theme of the binomial distribution. It's still a type of a probability problem, but we're finding x number of successes out of n trials. So another common problem would be coin toss. If I toss the coin 100 times, what's the probability that I will get exactly 7 of them will be tails? Or if I roll a die 10 times, what's the probability that exactly 3 of them will be 4? Like the 4 is up. So these are the type of problem that we can use binomial distribution to find the probability. So make sure to pay attention to the wording of the problem, because it is not only important to know how to apply this formula, but also know when to use these formulas, which means you need to be able to recognize when we have a binomial distribution problem.